Hello YouTubers, this is going to be a short demonstration in basic logic gates. I hope to get many short video tutorials out there to help demonstrate the basics behind electronic design. In digital electronics, there can be only one of two possible binary states for both the inputs and outputs of logic gates. Basically, they can be either 1 or 0. 1 being a high signal, usually plus 5 volts or 3.3 volts, 0 being a low signal, 0 volts. The tolerance for the IC will be found in the datasheet for that IC. Typically, they will start switching from anything above 0.7 volts. For this reason, all inputs must be given a definite high plus 5 volts or low 0 volts and not left floating, where they basically act like little antennas picking up random voltages from the air, causing them to switch between states rapidly. I have set up 3 ICs on the project board to show the basic building blocks of how they are combined into a single IC. On the left here, I have a 7408 AND gate. This IC has 4 2-input AND gates, and we are only going to be using the first one. It is good practice to ground the inputs of the unused gates, as they will fluctuate between a high and low state, causing unnecessary load on the IC. However, in this case, I am leaving them floating, so not to clutter the board, so it's easier for you to see what is going on. If we press the A button or the B button, you'll see that the inputs illuminate. However, the output remains low. But when you combine the two, pressing A and B together, you can see that the output is illuminated, therefore it is high. In essence, an AND gate has to have both A and B high so that the output is high. You'll also notice that I have resistors connecting the switches to the ground plane so that the inputs to the AND gate are not left floating. This is so that they do not rapidly switch during the momentary press of the switch. I paused the video to construct the NOT gate. I'm going to be using a 7404 over here. Basically, the output of the NOT gate is in a high state as the input is in a low state. It will invert whatever the input is. So if it is a 1 on the input, it will be a 0 on the output. If it's a 0 on the input, it will be a 1 on the output. If I press the A, inverting it, you'll see that the A is high and now the output is low, and as soon as I remove my finger, it reverts back to its original state. I've set up over here a NAND gate. It's basically a combination of a AND gate with the output going through a NOT gate, so that the output is the inverse of an AND gate. It works in exactly the same way as the AND gate did. However, the output is inverted. So both A and B have to be on for it to be off. So if A is high and B is high, then the output is low.